This is the answer key for the heat equation credit recovery assignment. The following terms have been defined here, and we are going to go ahead and do the three problems that go with this. So the first question, how many joules are there in 56 calories? So we need to go from lowercase calories into joules, and this is a one-step conversion using that conversion right there. So we're going to start with 56 lowercase calories, and we are trying to get to joules. We put lowercase calories on the bottom so they cancel, and we put joules on top, and numerically 1 lowercase calorie is 4.184 joules. So we have a multiplication situation in terms of units canceling. We are going to cancel lowercase calories on the top and the bottom and the top. The only unit we have left is joules, so we know we did the right thing. So this is a multiplication situation because the numbers are on top, or the subsequent number after the 56 is on top. So we're going to go 56 multiplied by 4.184. We're going to get 234.3 joules. If we wanted to go letter of the law with scientific notation and significant digits, we have two significant figures in 56, so we need 2 in this number here. So we're going to say 230 joules. In scientific notation, that would be 2.3 times 10 to the second joules. Remember, in scientific notation, our first number always has to be between 1 and 10. Second problem, how many calories are there in 252 joules? So this is the other direction, so we're going to go from joules into lowercase calories. So we start with 252 joules over 1. We use the same conversion factor, but we flip it over this time because we want to cancel joules and get to lowercase calories. Again, there are still 4.184 joules in 1 lowercase calorie. We are going to cancel joules. The only unit we have left in our problem is lowercase calories, so we know we are in good shape. And so now we are ready to use our calculator. So we have 252 joules as our starting point. We have 4.184 on the bottom, so this is a division problem. So we're going to go 252 divided by 4.184. Again, significant digits and scientific notation. We've got 3 significant digits in the problem, so we're going to put 3 in our answer. So we have 60.2 calories. If we wanted to go scientific notation, we would go 6.02 times 10 to the first lowercase calories. Now we're down here to the heat equation problem. So the question is, how much heat is transferred when 58 grams of copper is heated from 25 degrees Celsius to 78 degrees Celsius? We want to list all the variables in the space provided and then solve. So 58 grams, that is a mass. So we can list that there. Okay. Our element is copper, and so the specific heat value changes depending on what substance we have. And a lot of times the value is given in the problem, or a table is given and we look it up. So we have copper, and so we have 0.387. So our C value, right there, is 0.387 joules per 1 gram times 1 degree Celsius. Our final temperature, so we took care of the copper, our final temperature is 78 degrees. Our initial temperature was 25 degrees. So we're going to go 78 Celsius minus 25 Celsius. For a total temperature change of 53 degrees Celsius. So we have now everything in place now to use the heat equation, which is Q equals MC triangle T. Remember that triangle T can be written as TF minus TI, or it's the change in temperature. And how do you find a change in temperature? You take the final temperature minus the initial temperature. So here we go with Q. We've got 58 grams. Q, how much heat? Heat is measured in joules. So unit-wise, we should solve out and have joules. Let's see what happens. Our C value, I could do it this way, is 0.387 joules over 1 gram times 1 degree Celsius. And then our temperature value is 53 degrees Celsius. So I could set this up just a straight multiplication like, but it also works, this way. These bars, again, just mean multiplication. So in terms of units, we have grams on the top and grams on the bottom. We have degrees Celsius on the bottom and the top. The only unit left is joules, so we know that we are in good shape, and our answer is going to be in joules. So we are now ready for our calculator. So our Q value, we go 58 multiplied by 0.387 and multiplied by 53. So it's multiplying straight across. So 58 multiplied by 0.387 and hit equals. And multiply by 53 and hit equals. So we get a Q value of 1189.6 joules. If we wanted to go significant digits, scientific notation, and we're not going to be asked to on the diagnostic, I don't think, but letter of the law, our problem had 2 significant figures. So if we wanted to round our answer, we would take the 1 and the 1, the 8 rounds the 1, so we would say that this is approximately 1200 joules. But either answer of those is most likely going to work. So we've taken our variables, listed them, and solved for the missing variable in this case. Our units match up, 1189.6 joules, or approximately 1200 joules.